Okay, here's a magic trick. Imagine I have a bowl filled with liquid and all of a sudden this happens. What's happening here is that the liquid is climbing on the walls of the bowl until, well, there's nothing left. Plot twist, this actually isn't a magic trick. It's superfluidity. A superfluid is a fluid that has no friction or viscosity. On Earth, we can create a superfluid with liquid helium, two types to be exact, helium-3 and helium-4. However, the most easiest is with helium-4. For a superfluid state to occur, scientists must densely pack the particles in helium together to form an extremely dense state of matter. Then as helium-4 reaches absolute zero, specifically at 2.17 Kelvin, this point is known as the lambda point, it undergoes a transition from being a normal fluid to a superfluid. When liquid helium-4 reaches its lambda point, all kinds of crazy things happen. Because of the zero viscosity state that defines superfluidity, liquid helium-4 basically defies the laws of gravity and climbs up the walls of the surface it's contained in. Not only that, but even more crazier things occur, from creating infinitely swirling vortexes to leaking out of the tiniest microscopic holes in a glass beaker. So you may be thinking, what makes liquid helium so special that it turns into a superfluid as it approaches absolute zero? However, everything else turns into a block of ice. Well, let's first keep in mind a rule in quantum mechanics that states all molecules and atoms have specific discrete amounts of energy. What this means is that a particle can only have specific energy values that are valid. With that in mind, helium-4 contains 2 protons, 2 neutrons, and 2 electrons. These features allow helium to be more likely to become a boson. A boson is a type of particle that has the ability to be in the same energy state as its neighboring particle. In order for a fluid to be a superfluid, all of the molecules must be in the same state of energy. Scientists believe that this phenomenon has to do with the Bose condensate. To further understand this, imagine particles inside liquid helium turning into waves. Then as the temperature gets closer to the lambda point, all the waves overlap each other such that each individual wave can't identify itself anymore. What this means is that all of the neighboring particles are in the same energy state, and there is no way to tell each particle apart from the rest. Not only on Earth, but scientists have found superfluidity in space. In the remains of a supernova called Cassiopeia A, researchers found its core to be superfluid. However, the core is almost 1 billion degrees Kelvin, completely opposite to the temperatures of superfluidity required on Earth. This new findings allow scientists to understand more about the ultra-dense matter that they know so little of at this moment. Scientists also have a theory that states that dark matter could be a superfluid. Why? Well, we know that a superfluid needs to be squeezed in order to form a dense state of matter, and the natural pull of a galaxy performs that. And scientists already know that dark matter is extremely cold, as is most of space. This makes it the perfect place for superfluidity to occur. Overall, superfluidity can help answer questions that scientists have been asking for ages.